In this video, I'm going to translate the UML diagram for rectangle to Java, and then in the following videos, we'll take a look at some classes that we're very familiar with by now: scanner, string, and random. For now, here's a direct translation from the UML from UML to Java. So we have public class rectangle coming from the top of the UML diagram there. Inside this class, it looks like I have four properties. They're all listed as public because there's a plus next to them. Public int x, public int y, public int width, and public int height. Now I have a public constructor method. We'll learn more about these next week. Rectangle. It's got four parameters: x, y, width, and height. So it looks like the xy is the top left corner of the rectangle, and then it tells you how wide and high it is. So we have int x, int y, int width, and int height. And we'll worry about what it actually does later. I'll just put empty brackets for now. The UML diagram, again, doesn't tell us anything about what these methods actually do. That would be Java doc that we could write inside the above the methods to have more information about that. The constructor method is always going to take care of making a rectangle and returning it to you, and we'll practice making those ourselves in the next chapter. But for now, just going down the list and translating. Public string to string. I know it returns a string because this thing is the return method. This string that happens after the colon is always the return, the return type of the method. It doesn't take any parameters. We don't know what it does. Looks like a public void grow, which hopefully is actually going to modify those width and height values. Looks like a horizontal direction in H and a vertical direction in V. And we don't know what it does. It doesn't return anything, but hopefully it's going to modify those width and height variables. Seems like the name of it suggests that. And also we have a public void translate, which I'm hoping is going to modify the x and the y variables based on the names of these things. Int dx, which will usually mean a change in x, and int dy, which would be a change in the y value, and we don't know what it does. And then here's the end of my class. So this is the skeleton of a class written just from a UML diagram. I like UML diagrams very much because it allows me to think about the structure of a program before I write any code. And there's a whole, of course it's important to learn the syntax of programming languages and to understand how programming languages work, but there's I think an even more important part of computer programming, which is thinking about the whole problem space before you even sit down at a computer, and understanding how the data is going to flow and what the big chunks of your program are and how they're going to talk to each other. And I think this is most easily done in graphical form. It also means it's not language specific. So you don't have to pick your programming language at this point. You can just be talking at a very high level about pieces of your system. And when you're dealing with very large systems and multiple engineers, this is just about the only way you can have a concrete conversation about how things are going to talk to each other, because nobody has to think about code. You can just think about the logistics and how the data is going to flow from piece to piece. So just to give us more practice making UML diagrams and then translating them to Java, I'll take another video to show how some of the classes that we have known already, string, scanner, and random, would fit into this model.